Hey guys, we're still looking at inverse functions, and what we're going to talk about are one-to-one functions. A function has an inverse function. Okay, all functions have an inverse relationship, but meaning I have one function, I take the inverse of it, I get another function. So a function has an inverse function if it is a one-to-one function, and that's just what we call it, one-to-one. Okay, one-to-one. A function is one to one if it meets two criteria. And granted, I agree that just talking about these are abstract, but it's important to be able to talk about our postulates, our theorems, but it, because it helps us to visualize once we actually do an example and see it. So here are our two things that we can look at. The first one, different inputs, meaning different x values, domain, have different outputs, your y value. This goes all the way back to the beginning of our course. So different inputs, different x values have different outputs, y values. What I'm saying is that for this, different inputs, these are considered to be x values. I'm saying A does not equal B. Then they'll have different outputs. And this is y, these are y values, but written in function notation. So if A does not equal B, then f of A will not equal f of B, showing that the relationship between in the inverse relationship means that I have an original function, and after I take the inverse of it, I have another function. For A and B, choose opposites. So I can say a negative 3, 3, negative 2, 2, and it doesn't matter, it's arbitrary which set of opposites you choose to use. Pick a number that makes the math easier. The reason for this, and you'll see it in an example that we have coming up, is that in dealing with squared units, whenever I square a unit, it automatically becomes positive. Okay, but whenever I take the square root of it, I'm looking at the plus and minus values. So, criteria 1. Or we can use this one, criteria 2. Outputs are the same, meaning my y values, or written in function notation, f of a equals f of b. Then the inputs must be the same. Then a must be equal to b. And the reason that is because whenever we first talked about domain and range, only one input, so one value, so I have x and I can say x equals 1. It only has one corresponding output to be considered a function. And we dealt with that where we looked at different domains and ranges, but we're going to review it real quick. And we talked about the vertical line test whenever we looked at functions. But right now, we're not just looking at a function, we're looking at the inverse relationship between two functions and determining are both of them functions. So, for instance, here's my data for f of x. And if you'll notice, each individual value in the domain has a corresponding y value. It does not have two values. I'm not saying one can be 5 and one can be 8. I'm simply saying whenever x is 1, y is 5. But if you notice down here, I say whenever x is 3, y is 5. That is fine, as long as I don't say whenever x is 3, y is 5, whenever x is 3, y is 12. Each individual x has its own output. But whenever I take this, since I have two values of 5 in my range, remember I reverse my range and domain for an inverse relationship, I end up over here to where I say, okay, 5 is 1 and 5 is 3 for that inverse relationship. This inverse relationship, this equation is not a function because the domain limits it. Another way to look at it for your inverse, saying this inverse is not a function, whenever 5, when the x value is 5, so f of 5 equals 1. But also, whenever x is 5, it equals 3. Remember your vertical line test, I would intersect that function in two places. So that's us just pulling back, scaffolding some learning about what we've already covered, dealing with how I determine if a function is a function. We would use that vertical line test, or we could look at the domain, and if a single x value had more than one output corresponding to it, then we knew that that was not a function. But whenever we look at this for one-to-one, we're not just looking at a given function, we're also looking at that inverse relationship. Is the function I create by taking the inverse, or is the equation I create by taking the inverse of a function also a function? And we can do two tests on it. And here are some examples. So the first one was saying different inputs. So I have different x values. Remember, I make them opposite numbers. And then they have different outputs, meaning I plug in numbers from the range or domain and I get different values in my range. So what I chose 3 and -3. So I plug in 3 and I solve, and I end up getting f of 3 equals a -5. Then I plug in a -3 and I solve, and I get f of -3 equals a -7. These values are different. Therefore, f of 3 does not equal f of -3. It is a one-to-one function. Meaning whenever I take the inverse of this, the inverse of this function will also be a function. Or I could look at the other way of doing it and saying whenever f of a equals f of b, then a equals b, meaning my outputs are the same, therefore my inputs will be equal. So what I do is I simply take my function 1/3 x minus 6 and I replace the x value with the a value. So 1/3 a minus 6, and then I do the same for f of b. I replace x with b. I set them equal to each other and I solve. Add 6 to both sides, multiply both sides by 3, I end up with a equals b. One-to-one. Now, not all inverse relationships go from yes, this is a function to yes, it is a function. This is an example. Doing the first criteria, and I picked a is 2 and b is a -2. So whenever I plug in 2, that square is what makes the difference. I end up with f of 2 equals a -3. See, 2 squared is 4. The reason it is because whenever I plug in the opposite, -2, -2 squared is 4. I end up with them being equal. And this should make sense. This is a quadratic. This is going to graph as a parabola. So f of 2 equals f of -2. That's saying f of a equals f of b. Therefore, not a one-to-one relationship. And here, this may help looking at this right here. The second criteria. Whenever I'm going to set my f of a equal to f of b. Again, all I did was replace x with a and replace x with b. I set them equal to each other and I solve. And whenever I get down here, I have the square root of a squared equals the square root of b squared. Well, what may simply be thought is that I say, oh, well, that's a equals b. It's actually plus or minus a equals plus or minus b. So you have 4 options there. 2 of them are true. I can say a equals b, or I can say a negative a equals a negative b. But as I cycle through these different options, the bottom 2 are not. A negative a does not equal b, and a does not equal negative b. Therefore, this is not true. And it is not a one-to-one function. And we'll look at that whenever we look at the horizontal line test showing you about parabolas and quadratics. But for right now, let's look at a couple of examples. So, the first way to turn around and be able to look at it and work it is to simply say if A, oops, if A does not equal B, then f of A does not equal f of B. So pick some numbers. I'm going to say A equals a negative 4, and I'll pick the opposite, B equals 4. So we'll look at f of A first. So f of a negative 4, and all I do is I take negative 4 and I plug it into my function. I'm saying f of a negative 4 equals a negative 9. And then I do the same over here. I say f4 equals, and I plug in f of a negative 4 does not equal f of 4. 1 to 1. My A and B were not equal. My f of A is not equal to f of B. See, negative 9, 7. Or I could turn around and say f of A equals f of B, then A equals B. And then what I do is I replace my x values with A and my x values with B. So what I'm left with is 2A minus 1 equals 2B minus 1. Add 1 to both sides, divide both sides by 2, I'm left with A equals B. Therefore it is 1 to 1. Here, same thing. If A does not equal B, then f of A does not equal f of B. So let's say, we'll say it. A equals a negative 2 and B equals 2. Four-fifths for that one. 4/9 for that one. So I know that f of a negative 2 does not equal f of 2. And that's what I needed. My A and B were not equal. Then f of A should not equal f of B, and they did not. Or I could follow suit up here, and I could set them equal to each other. Again, I take A and substitute it for x, and I take B and substitute it for x. So what I end up with is 4A plus x equals 4B plus x. For this one, I'm going to treat it like a proportion. I'm going to cross multiply. And we'll say 4 times B plus 7 equals 4 times A plus 7. I'm going to divide both sides by 4. I'll write these out in more steps. I'm going to subtract both sides from 7, and I end up with B equals A. Therefore, 1 to 1. Alright guys, sorry about the time length of the video, but sometimes these calls for just a little bit more explanation. Watch your publisher's videos, critically think, structure your homework, and good luck on your homework.